We're continuing on in substitution, and specifically now we are starting to look at examples where we have to find definite integrals using our substitution technique. I want to refer back to an example that we already did as an indefinite integral. We found the indefinite integral of x times the quantity x squared minus 3, all of that squared. And now I'm adding another piece to that to show you how it works if you're asked to find a definite integral. Remember, a definite integral is a specific net change in a quantity or net area. So we're going to come out with a number rather than a function. So remember that we had done our u substitution. U was x squared minus 3 and so on. And after we did the substitution and then found the antiderivative, we ended up with 1/6 u cubed. You can go back to your notes or go back to the original video to take a look at that fully worked out problem. Now, there's two ways we can go. One is we can stop here and now evaluate our definite integral. But notice that our lower and upper boundaries have changed. Our original lower and upper boundaries were based on the value of x. So we said we wanted to find the area of the curve when x was between 1 and 2. But now we're using a different variable called u, which is based on x, but it isn't x. So here I've used the g notation, but you could use the u notation. I have to look at what my definition of u is. U is x squared minus 3. My original boundary is for x, my lower boundary is where x is equal to 1. So I have to substitute that into my expression for u to see what my new lower boundary is if I'm going to use the variable u. So I would take u of 1 and u of 2, and I would get my new boundaries, and then I would go on and I would evaluate the definite integral as normal. Or you can go forward and you can back substitute x in for the u. So we're substituting x squared minus 3 in for the u. And now we can go back and we can evaluate at the original lower and upper limits. Let's go on and take a look at an example that we have not done before and see how this works. So we have dx over 1 plus square root of x and all of that raised to the 4th power. Now the first thing I'm going to do is rewrite that in a slightly different form and see if I can get any ideas of how to figure this out. The first steps are exactly the same as what we did for indefinite integrals. We need to find the antiderivative, so we need to get this in a form where we can do that, and we use this technique of substitution to help us along that path. So it looks to me like I have a composition. Something is being raised to the negative 4th. So my u is going to be what looks like the inner function, x 1 plus the square root of x, or I've written it as x to the 1/2. So the derivative of that, 1/2 x to the minus 1/2 dx, and therefore dx is equal to 2x to the 1/2 du. Now notice we're all of a sudden going to be introducing something new that wasn't there before in our original function, but you've seen that we figure out ways to deal with this. So now let's start doing some substitution and we'll see where we are and then where we have to go. Remember, we want to find something that is all based on u. We want to get rid of all the x's. So that 1 plus x to the 1/2 to the minus 4 we can write as u to the minus 4. Great. But now dx is introducing another x in here. All right. So, okay, we'll deal with that. We'll deal with this new x to the 1/2 that wasn't there before because we want this all to be legitimate. And we see that our original expression for u is equal to 1 plus x to the 1/2. Therefore, x to the 1/2 is equal to u minus 1. So we go ahead and substitute that in. And we're going to have to do some simplification, like distributing the 2 and then multiplying by the u to the minus fourth. Make sure you got all that algebra down. And we end up with the definite integral from 0 to 1, 2u to the minus 3 minus 2u to the minus 4 du. All right, I'm going to go on to the next slide, so you should pause it here if you still need to look at this paper. All right, so here's where we were, right there at the top. Okay, that's where we left off on the previous slide. Now we're at the point where we can find an antiderivative. So finding the antiderivative, 2u to the minus 2 over minus 2 minus 2u to the minus 3 over minus 3. And notice my lower and upper limits now. I have to figure out from my original lower boundary of 0, what is the value of u? Well, I have to substitute 0 in for x to figure out what the new lower limit for u is. And I have to substitute a 1, the upper boundary, a 1 in for x to figure out what the new upper limit for u is. And I go ahead and do that, and now my new lower end limit is 1 to 2, so that's based on u. So now I can go ahead and do my evaluation. I'm going to substitute 2 in for u in the first part, and then I'm going to subtract the expression when I've substituted 1 in. This is just exactly the way that we have evaluated definite integrals in the past. So I'm going to do the same thing. Now you got fractions to deal with, but you're going to simplify everything and you'll end up with 1/6.